Guys, welcome back to another episode of AP Torture. I'm Jake,
And I'm Collin.
and today we're going to be studying organic chemistry. Organic chemistry is the special study of covalent bonding. What is it? It involves hydrocarbons, which are chains of carbons bonded together to create many different shapes and figures. When naming these hydrocarbon chains, there are three families: the alkanes, alkenes, and alkynes. Alkanes contain only single bonds between the carbons, and their names always end in "ane." Alkenes contain at least one double bond, and their name always ends in "ene." And alkynes always contain at least one triple bond, and their names end in "ine." Based on the amount of carbons in the longest chain, known as the parent chain, the name of the compound contains set prefixes. For example, if there are 7 carbons in the parent chain, the prefix would be hept, and if the parent chain was made out of all single bonds, the carbon chain would be known as heptane. Let's do an example of how to name the prefixes of a ane group with only single bonds. For example, the parent chain of this one only has 3 carbons, which means that the prefix would be prop, meaning that this carbon chain would be named propane. And this one has 1, 2, 3, 4, 5, 6, and it is all single bonds, therefore it would be named hexane. Sometimes there are things called substituent groups, which are also known as alkyl groups, which are carbons that are not part of the longest chain of carbons. There are many types of alkyl groups based on the amount of carbons in the substituent group. A substituent group with 1 carbon is called a methyl group, 2 carbons is called an ethyl group, 3 carbons is a propyl group, and etc. The substituent groups is given a number based on which carbon it is attached to in the parent chain. The parent chain can be read from any direction, from left to right or right to left, but it should be read so that the numbering of the substituent group adds up to the lowest combination of numbers possible. For example, we have this carbon chain here. It has all single bonds, so you know that it will end in ane, because this is an alkane group. And the parent chain is 4, therefore the prefix will be bute. But we also have a substituent group, which is on the 2nd carbon. We could say it's on the 3rd carbon if we were reading from right to left, but the lower number would be 2, so it means we're reading from left to right. Therefore, the name would be 2-methyl butane. When there are multiple of the same substituent group, the name of the substituent group is denoted with a prefix. For example, if there are 2 methyl groups, they are denoted by the name dimethyl. If there were 3 methyl groups, they would be denoted as trimethyl. For example, here we have a alkane, so therefore it would end in ane. And the longest chain is 5 carbons. Therefore, the prefix would be pent. We have 2 substituent groups here. And they're placed on the 2nd and 3rd carbon, opposed to the 3rd and 4th carbon from the left. Therefore, since the 2nd and 3rd carbon create the lower combination of numbers, we're going to use that to label the 2 substituent groups. So they would be labeled 2,3-dimethyl, because there are 2 of them, 2,3-dimethylpentane. Sometimes there are carbon chains that have multiple types of alkyl groups, and they are named alphabetically and numbered to create the lowest combination of numbers. Based on the name of the substituent group, they are alphabetically placed in the name of the carbon chain. For example, ethyl will become before methyl, and which would become before propyl. Prefixes like di and tri do not affect this ordering. For example, here we have an alkane, which would end in ane, and the longest chain is 1, 2, 3, 4, 5, 6, 7. Therefore, the prefix will be hept. And we have two substituent groups. We have a methyl group and we have an ethyl group placed on the second and fourth carbon as opposed to the fourth and the sixth carbon, because the second and fourth will create the lower combination of numbers. So we have, because E becomes before M in the alphabet, we'll place the ethyl group first, which means we'll have 4-ethyl dash 2 dash methyl heptane.
Hey guys, Collin here. Next, we have alkenes, which contain at least one double bond. The double bond is named just like substituent groups. On the carbon, it is located to create the lowest combination of numbers. For example, if there is a parent chain of 7, in which there are double bonds on the first and third carbons, and there is an ethyl group on the fourth carbon, it would be named as such: 4-ethyl 1,3-heptadiene. Alkynes are named in the same manner as alkenes, except alkynes involve triple bonds. The triple bond is named and numbered just like substituent groups. On the carbon, it is located to create the lowest combination of numbers. For example, if there is a parent chain of 7 and the triple bond is on the first carbon, the name would be 1-heptine. Here's an example of an alkyne with a substituent group. If there was a carbon chain with a parent chain of 8, a triple bond on the first carbon, and a methyl group on the third carbon, the name would be 3-methyl 1-octine. When there are multiple triple bonds, the prefix to denote how many triple bonds there are is the same as substituent groups, such as di, tri, and etc. But the prefix is placed in between the prefix of the parent chain and the suffix of the family that the carbon chain belongs to. For example, if there is a parent chain of 7, triple bonds on the first and third carbons, and an ethyl group on the fifth carbon, it would be named 5-ethyl 1,3-heptadiene. Now we're going to work backwards with some examples. Pause the video and draw 3-ethyl 2-methylhexane. Here's the answer. Knowing that it's hexane, all of the bonds are single bonds, and there are 6 carbons in the parent chain. Next, it says 2-methyl, meaning that on the second carbon there is a methyl group. And 3-ethyl means that on the third carbon there is an ethyl group. Next, we're going to try drawing alkenes and alkynes. Pause the video and draw 2,3,4-trimethyl 1-hexene and 3-ethyl 4-methyl 1-octine. Here's the answer to the alkene. Knowing that the ending is hexene, it is 1-hexene, so there is 1 double bond on the first carbon, and there are 6 carbons in the parent chain. Next, it says 2,3,4-trimethyl, meaning that on the second, third, and fourth carbon, there is a methyl group. And now here's the answer for the alkyne. Knowing that the ending is 1-octyne, there is a triple bond on the first carbon, and the parent chain is 8 carbons. Next, it says 4-methyl, meaning that on the fourth carbon there is a methyl group. And 3-ethyl indicates that on the third carbon there is an ethyl group. Good luck next year in AP Chemistry.
So I did.